All right, guys, as we wrap up the year here, I do have 2 additional topics this week that would be good if you completed these 2 assignments. They're really the last 2 things that would be on the AP exam. And then I'll give you some other study resources that you guys could do on your own if you choose to. This one will be required for a grade, and then the next one on slope fields I'm going to make bonus. I would recommend that you do it, though. All right, so let's go ahead and look at these differential equations. So this is going to be a bit of just a sort of a different topic than what we've been doing with the volume and area. Differential equations are important, however, and these have to do with integration. So a differential equation is always going to generally start like this. It will say dy dx equals something. All right. So whenever you see that dy dx equals, think that's probably a differential equation. Dy dx equals. All right, dy dx, it's basically just another way of saying y prime. Okay, it means exactly the same thing. In fact, if you had y prime, you would actually want to rewrite it with dy dx. So it's basically saying the derivative of this equation is x plus 3 over 2y. Okay, because we're given a derivative. Dy dx, remember, is the different notation for y prime. All means derivative. It could also be the same as f prime of x, right? That all means the same thing, f prime of x. 3 different ways to write the same thing. All right, so basically what we're trying to do is we're trying to find y, or f of x. We're given an original derivative, and we're going to try to get what we're going to call the particular solution. Okay, so a particular solution just means that we have some initial condition, which is right here, and I'll talk about what that means here in just a second. So let's start with how we solve a differential equation. I'm just going to go ahead and rewrite it here. And generally when we've done integrals, we don't have both x and y variables in this integral in most cases. So what we're going to do here, the first thing that we're going to do is we're going to get all the x's on one side and all the y's on one side. It should be pretty easy. All we're going to do is multiply this 2y over to this side to make this 2y dy, and then times this dx over to this side. So it's x plus 3 dx. Okay. So I've just done some rearranging there. I just multiplied the dx over and I multiplied the 2y over both sides. Okay, so hopefully that makes sense. So our first step there is just to get the x's on one side, the y's on one side. Generally, you want to get the y's on the left side just because it's what you're used to. Okay, the next step we're going to do is we're going to integrate both sides. Notice we have the dy and the dx. That just tells us with respect to what variable we're going to be integrating to. So I'm just going to go ahead and throw an integral symbol on there and integrate both sides because we're allowed to do that. Just same principles for solving any equation back from pre-algebra. What you do to one side, you have to do the other, right? So we're going to integrate both sides. So on the left side, we're integrating with respect to y. So we add 1 and divide. That becomes 2 over 2, or just 1 y squared. And for right now, I'm going to go ahead and write plus c. Okay. And if you remember when we did this integration, there was always this constant we had to account for, this plus c, right? So I'm going to go ahead and write that. And then over here, I've got, this will be 1/2 x squared, right? Because I add 1 to the power and divide, plus 3x. And also we got a plus c here too. Okay. So we actually have 2 plus c's. Now that c, really we shouldn't actually call a c in both because they're different constants. So sometimes you'll see like a k. Let's go ahead and do that. Let's just call this one k right now. Okay, because it's a different constant. So that c is a constant, that k is a constant. All right, so when we find the what we're going to call the general solution, we're basically going to now solve for y. So if we were to move this constant over, this minus c, we're essentially combining k and c together, right? Which are just both arbitrary constant. So if we have an arbitrary constant and we subtract a different arbitrary constant, we actually just end up with some other arbitrary constant. So basically how this works out is we just have y squared equals 1/2 x squared plus 3x. And we can just call this plus c because whether you call it K or C, when you're adding arbitrary constants, you can combine them together. You just get, again, another arbitrary constant. Okay. So then last thing we need to do to get what we'll call the general solution is to just get the y by itself. Okay, so that's what we're trying to get. So we take the square root. All right, so we get y equals square root of 1/2 x squared plus 3x plus c. Okay, so this is what we are going to call the general solution. The general solution. Sometimes you will be asked to find that. Okay, a general solution just means it still has the plus c. All right, so it just has the arbitrary constant there. I'm going to go ahead and erase some of that stuff up top so I can show you how to get the particular solution, which is what we're asked to find in this problem. Okay, so if we're asked to find the particular solution, we are now going to use this initial condition. Okay, so the initial condition says f of -4 equals 5. So this says if we plug -4 in for x, then our y will be 5. Just think of f of, when thinking about functions, plug a certain number in, you get out a y value, right? So if we plug in 4 for x, -4 in for x, then we should get out y. So what we're going to do is use this initial condition, plug it into the general solution to solve for c. So I'll show you how that works here. So y is supposed to be 5, so I'm going to replace y with 5 equals square root 1/2 and then -4 squared plus 3 times -4 plus c. Okay, so what I've done is replace my x's and y's with 5 and -4. And then now I need to solve for c. So just doing some algebra here, we get 5 equals square root of 1/2 times 16 minus 12 plus c. All right, so then we get 5 equals, that's going to give us 8 minus 12, so it'd be -4 plus c. All right, and again, we're trying to solve for c, so let's go ahead and square both sides, square it, square it. We get 25 equals -4 plus c. We'll then add the 4 over, so c equals 29. Okay, so now the very last step is now we're going to plug that in for c. Plug that 29 in. So our final particular solution will then be y equals the square root of 1/2 x squared plus 3x plus 29. That is our particular solution, which solves that differential equation. So square root 1/2 x squared plus 3x plus 29. All right. So I'll go through this again, walk out the steps here. Once you get the hang of this, it really isn't bad. So I guess if I were to just go ahead and write out steps, if you're a step person. All right, so first step is going to be to group x's and y's on separate sides. Oops, sides. The next step is going to be to integrate both sides. Integrate both sides. After that, we're going to solve for y. Let's get the y by itself. Get y by itself. All right, after that, that's going to give you your general solution. After we've done that, we're then going to plug our initial condition. Plug initial condition and solve for c. And then last step is to just write particular solution by plugging then for C. So if this was a traditional classroom, I would write out some steps like this. Tell you to write them down if you want to. Here's our general process here. So we group both on each side, integrate both sides, get the y by itself, plug in the initial condition to solve for C, and then write our particular solution by plugging C into the general solution. Okay, so let's do that. So we got dy dx equals 2x minus 3 over y. So my first step is going to be to rearrange that. I'm going to write y dy. We always write the variable in front of the dy as well. So again, we're just times it by y, times it by y. And then the dx over, we're just going to multiply 2x minus 3 dx times it by dx times it by dx. All right, so that's the first step, is rearranging. Next is to integrate both sides. So throw my integral symbol on. The left side, we add 1 divide, it becomes 1/2 y squared. Now this time, instead of writing like a plus c on the left side, I know that arbitrary constant is just going to combine on the other side. So I'm not going to write a plus c because it's kind of unnecessary. Whether you have an arbitrary constant either side or both sides, it really doesn't matter. So I'm just going to write 1/2 y squared. And then integrate my right side. So that's going to be add 1 divide, just becomes x squared minus 3x. And then I'll go ahead and put my plus c on this side. Again, we only need to really write it on one side. So next then is to solve for y. So I'm going to multiply the right side by 2. So y is going to be 2 times parentheses x squared minus 3x plus c. And then take the square root over that. So that is my general solution. 2 times x squared minus 3x plus c. That's the general solution. Okay, now we're going to use our initial condition, which was f of 3 equals negative 6. Remember, this is the x and this is the y, to solve for c. So we're going to have negative 6 equals square root 2, and then we've got 3 squared minus 3 times 3 plus c. So let's go ahead and solve. Negative 6 equals square root of 2 times, that'll be 9 minus 9, right? So that's actually going to be 0 plus c, so that's actually just c. And then let's go ahead and square both sides. So we get 36 equals 2c, and then divide by 2 to get c equals 18. Perfect. So now our particular solution then is y equals square root, let's see, delta math probably would appreciate if you went ahead and distributed that 2 in. So let's do that. We'll make this 2x squared minus 6x, and that c is 18, so that 2 is going to get multiplied by the 18, so it'll be 36. All right, so that's, I'm guessing how they want you to write it in. Hopefully they're not too picky, which I know they can be sometimes. All right, let's go with that. Let's see here. All right, so it looks like what's telling us on this one is when we take the square root, when we solve for the y squared here, right, take the square root of that, we actually have to consider both the plus and minus roots. I didn't write that because generally you just always want the positive roots. But what it's saying is when it gives you a particular solution and the y value is negative, so in this case it was f of 3 equals negative 6, you actually want the negative root. So we just needed to throw a negative sign in front of there. So that's the one change we need to make on that one. So just be aware of that. If, make a note here, note if particular solution, or sorry, our initial condition, if initial condition y value is negative, then we want the negative root. All right, so just be careful on that. I know it's frustrating when you do a whole problem, you miss one little symbol and it counts it wrong. So on the AP test, if this was like a free response, you would get almost all the credit for this question. If you just miss the root, you would just miss one little point. So do not fret. All right, let's go and look at the next one. Oh, as just a note about the AP test, I think I've told you before, but you need a 3 out of 5 generally for college credit. So it's graded on a score of 1 to 5. You need to score a 3. A 3 is generally like around like maybe a 65% or so, give or take. Just depends on the year. So don't get discouraged on the AP test if you are missing questions, because your design's designed so that you miss questions. Very rarely do people get perfect scores. Sometimes I have had students get 5s, which is awesome. But again, don't get discouraged if you're not getting a 5, because, well, it's pretty hard. Okay, let's go ahead and do one more. So on this one, the particular solution is positive, so we want the positive root. So I'll just go ahead and make note of that. All right, and then let's go ahead and rearrange this. So it's going to become just y dy equals 2x dx. This one looks pretty easy. So then we integrate. That becomes 1/2 y squared equals just x squared plus c. It's pretty easy. And then when we solve this, we'll get y equals, and I'll go ahead and write the plus or minus root. I had thought about that at the beginning, but I didn't realize there would be situations where you'd want the negative root. So good habit to go ahead and write that. And then it's just going to be 2 times x squared plus c. So we have to multiply that 2 over first. All right, so that is our general solution. Suppose if you wanted to go ahead and just multiply that through, maybe that'd be a little easier. Plus or minus 2x squared plus 2c. That's fine to go ahead and do that. Now we can plug in our initial condition to get our particular solution. So let's write that up here. We would get 2 equals plus or minus, and actually we just want the plus root now because, again, this is positive. So we want the positive root, square root of 2 times 3 squared plus 2c. And that gives us 2 equals the square root of 18 plus 2c. Now I want to square both sides. So I get 4 equals the square root of, 4 equals 18 plus 2c. So we get negative 14 equals 2c. And then so c equals negative 7. Okay. So then we're just going to replace that in there. So we get y equals the square root of 2x squared and then minus 14. And that is all there is to it. Boom. All right, so that is it. That is differential equations. There are harder scenarios with this, but I just want you to get the basic concept here. Keywords here: general solution, particular solution, initial condition. So it doesn't actually say general solution, but again, that's what you get when you have just the plus c in it. The initial condition is what you use to find the particular solution. All right, good luck, guys.